Hello everyone. In this particular video we're going to be going over a couple assignments. One, evaluate inverse trig functions, and the other, solving sinusoidal equations, just the basics. So we're going to be going over that. Make sure you have your journal ready to go. We're going to be talking about the unit circle, and we want to make sure you understand how to interpret the unit circle when it's in radians versus degrees, because they'll be asking you questions about answers in radians and degrees. Remember, radians, you start from 0 pi, then pi over 2, pi, 3 pi over 2, and go all the way to 2 pi. Degrees, you start from 0 and you go all the way to 360. Just remember your quadrants. Remember the first quadrant, all of your x values and y values are positive. In the second quadrant, you have negative x values and positive y values. In the third quadrant, where most teenagers live, you have negative x values and negative y values, just everything's negative. And then in the fourth quadrant, you have positive x values and negative y values. So when it talks to you guys about like what's the range of the inverse function, when you're dealing with the inverse of sine, also known as arc sine, you can see right here, arc sine or the inverse of sine, when you're in degrees and when you're in radians, you're only going to be dealing with quadrant 1 and 4. Why are we only dealing with quadrant 1 and 4 when you're dealing with the inverse of sine? Why is that the range of this? Because here the y values are positive and here the y values are negative. So these are the only ones that you're going to be using. Answers there in quadrant 1 and 4. When you're dealing with cosine, though, you're going to be dealing with from 0 to pi or from 0 to 180. So you're going to be dealing with quadrant 1 and 2 because that's where your x value is positive and that's where your x value is also negative. All right? And then the reason it being is because you're going to have multiple answers if you chose to do more than just those quadrants. But we'll get into that as we do some questions. So the first question, let's take a look real quick at the first question right here. It says, the following are all angle measures in radians rounded to the nearest hundredth whose tangent is 3.7. Which is the principal value of arc tangent? So on this particular problem, all you're going to do, it's going to be very easy. You just put the inverse of tangent, 3.7. So we're going to type that in to the calculator right now. Make sure your mode is in radian mode, so hit the mode button, make sure it's in radian. Hit second tangent, type in 3.7, press enter, and you get 1.306. So 1.31 is the answer that we're looking for. Now in degrees, that would be, let's go and change over here to degrees. That mean? In degrees, that would mean it's about a 75-degree angle. But in our particular problem, it says in radians. So we see this 1.31, that's going to be our answer, and we're done. Let's do one more. This one says, which is the principal value of arc sine, or the inverse of sine, of negative 0.71? All right, now this one, it says, pay close attention, it says in degrees. So we're going to go to degrees, and I'm going to hit second sine, and I'm going to type in negative 0.71. So about negative 45.23 degrees. And that's the answer that I'm going to be looking for, negative 45.2 degrees. And that's all you have to do. Now, the next thing we're going to be talking about is dealing with, quote, quote, solving sinusoidal functions basic. And this is going to be where you're going to need to draw out a unit circle. So what I'm going to do right here is I'm going to pause the video, I'm going to draw my unit circle, I'm going to get everything set up, okay? So we're going to be looking at all these possible answer choices, and we're going to select all the answers that apply to this question. Now that I have my unit circle set up, you can go and pause the video if you want to draw your own. I want you guys to think about the sine of x equals negative 0.25, as I also want you to think about it as the fraction of negative 1 over 4. Now remember, the sine, when you're dealing with the unit circle, is always the y value divided by the r value. So one thing I'm going to quickly do is I'm going to go over the quick trig, quick little reminder here. The sine of theta is always the y value over the r value. The cosine of theta is your x value over your r value meaning the radius, and the tangent of theta is the ratio of y over x. All right, so these are your basic ones, so we're going to be using that right now. So right now I want you to understand that they're telling us basically that our y value is -1 and the r value is +4. Now what does that mean for us? That means that there's two different places where the y values can be negative. The y values can be negative in the third quadrant and the fourth quadrant. And it's saying our y value is -1. So I'm going to draw just an approximate situation of what we have right here. All right, I'm going to draw a right triangle in the fourth quadrant and in the third quadrant. So here we're in the third quadrant. Here we're in the fourth quadrant. And remember, here our x values are positive and our y values are negative. Over here, our x values are negative and our y values are also negative. So I want you to think of this distance right here being like that. They're saying this is -1 and this distance right here is -1, but our radius is 4. So we're going to find theta right here, like what is theta right here and what is theta right in here. That's what we're going to be doing. And now it says we need to be in radians, okay? But I'm going to go ahead and start out in degrees, and then we're going to convert it to radians just to make it a little bit easier. So we're going to figure out what is the measure of theta right here, and what would be the measure of theta if I started right here and went all the way around to right there. What would be the measure of theta right there? So go and get your graphing calculator ready. This time we're actually going to use Desmos to type things in. All right, so I'm going to go to Desmos right here. First thing I'm going to do is I'm going to change this to radians. Go over here, go to functions, type in the inverse of sine, and look back at my problem, which says -0.25. Alright, and so there's my answer in radians. Alright, now I'm going to take a screenshot of that. Then we'll go ahead and take a look at what our answer would be in degrees. Alright, there's our answer in degrees. So we have radians and we have degrees. So when it says the sine of x equals -1/4, and we're wanting to solve for x. Basically, we're trying to figure out what is theta. What's the angle that creates this ratio of -1/4, which looks like this triangle right here, or looks like this triangle right here. That's what we're trying to figure out. And so what it tells us, it says that x is equal to, and if you remember what we have to do to both sides, we have to apply what's called the inverse on one side, and we have to apply the inverse on the other side of the equal sign, and that's why we say x equals the inverse of sine. So these cancel out, and we're left with what theta is. All right, so the inverse of -1/4 ended up approximately being -0.25 radians. All right, so what does that mean for us? That means right here, theta, we'll put theta right there. Right here, we are at -0.25 radians. Now, how can I get to this point right here? Well, I can simply add 2 pi times any integer, whether the integer is positive or negative, times any integer, and that will get me right here every single time. So -0.25 plus 2 pi times n will get me there. So I know one of my answers is going to be -0.25 plus 2 pi. And so I know one of my answers is going to be C. So now we're going to figure out, like, how do I get right here every single time? Now, basically what you can do is you can start here and we can travel all the way across to right there. So we're going to figure out, like, what is theta from here all the way across, and that will get us to this point on the unit circle. So that's the next part we're going to do. Now, we already know that theta right here is -0.25. All right, and we know that all the way from here all the way across is 180 degrees, also known as pi. So if you wanted to figure out the gap from here to here, which you could do, all right, I'll use Desmos. You could take pi, all right, and you could take away 0.25, and you're left with 2.89. Now, what does that mean? That means from here to here, now if we travel this direction, that's negative. So that's actually negative 2.89 in radians. Now, what would that be in degrees? In degrees, we could take this answer right here, and we could multiply it by 180 divided by pi, and that will convert it, if you guys remember that. All right, so hold on, I better put this in parentheses, because parentheses, they matter. They matter. There we go. Okay, that's much better. Now, what does that 160, basically 166 degrees mean? Now, a positive 166, let me go back to our problem. A positive 166 degrees would start here, and you would end up right over here. But a negative 166, or a negative 2.89 radians, will end us right there. So I'll do it one more time. If you go counterclockwise, that's positive. So like right here, I'm about 45 degrees. Right here, I'm at 90 degrees. Right here, I'm about negative 135. Here, I'm at, sorry, not negative, positive 135. Here, I'm at 180. So if you go this way, that's positive. This is going in a positive direction. But if you go clockwise, that's negative. So that's why we have to call this from here to here negative 166 degrees versus positive, which means from here to here is negative 2.89 radians. So what does that mean? If I'm at negative 2.89 radians, how can I get there every single time? Well, I can also add 2 pi times any integer. So I can either use this one or I can use this one right here every single time, and that will get me to this spot, or it will get me to this spot. Now, if you want to know how to kind of sometimes check your answer right here, you can go in here and go into Desmos or your graphing calculator, either way. I'm going to start with negative 0.25, and I'm going to put plus 2 pi x, and just create a table. All right, and right here, basically, we're just adding 2 pi to each. Basically, right here, these just represent the integers that get to that negative 0.25. The other one that we had was negative 2.89 plus 2 pi x. I'll make a table out of this, and you can see how we got to that negative 2.89. And then from there, you're just adding 2 pi in both directions, either positive or negative 2 pi. All right. So if, for example, you wanted to check to see if you're able to find these terms right here, this negative 0.25 and this negative 2.89, then you could go back and you could check some of your other answers. For example, negative 0.25 plus n times pi will eventually get you there if that becomes a 2, but it doesn't get you there every single time. I'm going to go ahead and just select the answers and move on for this particular problem. Wrong one. This one, and this one, A and C. Alright, now what we're going to do on this one, once again, we are solving basic sinusoidal equations. Alright, we're going to pay very close attention. This one's in degrees. We're going to round it to the nearest hundredth, and this one creates a boundary between 90 degrees to 450 degrees. So that's basically, we're going to find all the different degrees between 90 and 450 that match up to cosine of 0.2. So I've drawn my unit circle. I'm going to change my decimal to a fraction, 1 over 5. So we're going to solve. We're going to go ahead and solve for x. Cosine of x equals 1 over 5. To solve for x or to solve for theta, to figure out the angle, I want you to understand we have x over r. This is the x value over the r value. So our x value is 1 and our r value is 5. So basically, what is that? What do those triangles look like? Basically, you go over 1 and you go right here. That could be a 1 to 5 ratio. 1 being here, 5 being here. We could also create a triangle that goes down like this. So understand, x is positive in the first quadrant and also in the fourth quadrant. So these could be the two places that we could end up being from right here and right here. And right now, we're going to call that theta. That's going to be our x value. And here's also theta right here. I can draw it in, dadgummit. Well, just know that right here, that's also theta. All right, and this is 1 unit. This is 1 unit long from right here to right there. Here we're going to have a positive theta. Here we're going to have a negative theta. So once again, to solve for x, all we have to do, x will equal the inverse of cosine. And we're just going to do 1 over 5. And we're in degrees. Yeah, it says we're in degrees right here. So you can go over to your Desmos if you want to. Go and close this out. You just type it right here. Go to your function, type in the inverse of cosine, and you could do 0.2 if you want to, or 1/5. It tells you right here, if you want to get to degrees, you got to make sure you're not in radians this time, which will give you 1.37. Make sure you're in degrees, which gives you 78.46 degrees. So I'm going to take a screenshot of that. Go back. So basically right here, this angle right in here, that angle is 78.46 degrees. This angle right in here is going to be negative 78.46 degrees. Now this problem is going to be a lot easier because all I have to do is take 78.46 degrees and add 360 to it, or I can go right here and take negative 78.46 degrees and add 360 to it. Okay? So we're going to create a list right now. Let's go to our calculator. I'll use Desmos. You can use your graphing calculator if you want. We're going to take negative 78.46. We're going to add 360. And that puts us at 281.54. So we know right here, I'm going to go ahead and bubble in a couple of answers. We know one of our answers is negative 78.46. We know another answer is positive 78.46. We just found out another answer, which was 281.54. Now, why is that an answer? Because it's between negative 90 and 450. So let's see if we can find another one here. All right, let's go ahead. Oh, wrong one. Let's add another 360. Oh, that puts us at 640. That's not going to work. All right, so let's go back. What if we just change this to a positive 78? Ooh, we're at 438.46. That's between them. So we'll go back over here. And there's the last one that I need right there. All right, so just a quick little review. What did we do? We took negative 78.46 and we took positive 78.46 because we found the inverse of cosine and found that to be 78.46, and then all we had to do was just add 360, and then we had to add 360. This one became 438.46, so we selected this one right here. And then this one became 281.54 degrees. So we selected this one as well. So what did you have to do? A quick little review. We had to find theta. We needed to understand that cosine 0.2 could either be in the first quadrant or the fourth quadrant, because remember, in the first quadrant your x value is positive. In the fourth quadrant your x value is also positive. So 0.2 could either be in this quadrant or this quadrant. That's why we got the 78.46 and a negative 78.46. Then we just added 360. to get the other two answers. Now we didn't add negative 360 because it said it stopped at negative 90, so that's why we didn't add negative 360. So I'm going to go ahead and select these answer choices, which is A, C, there we go. Let's select them. We got A, C, D, and F. Okay. All right, so this one's similar to kind of the first one that we did, so we'll go ahead and do one more of these and see if this will be helpful. So I'm going to make my unit circle right now. All right, so here's our unit circle. Once again, it looks like we're also, once again, we're in negative 0.55, so that's going to put us, where is sign negative? Sign is negative in the fourth quadrant and also the third quadrant. So we're going to be in quadrant 4 once again, and we're also going to be in quadrant 3 once again. So I'm going to go ahead and solve this out. I said the sine of x equals negative 0.55. X will equal the inverse of sine of negative 0.55. Alright, and that basically is going to put us in the fourth quadrant and the third quadrant. We'll kind of figure out where that is in degrees and also in radians, and I'll kind of draw my triangles. Okay, so I'm going to go over here, clear that out, clear this out, go to my functions, hit inverse of sine, negative 0.55. So basically I'm at negative 33.36 degrees. It'll help me draw my unit circle. So I'm going to go ahead and draw that. So negative 33 degrees is going to put me right about here. My other triangle will look very similar, just be in quadrant number 3. Alright, so now what does this mean? That basically means this fraction is negative 55 over 100, which basically means, like, this side is negative 55, then the radius is 100. Over here we're at also negative 55, and this radius, the r value, is also at 100. So we're going to find theta right here, which we just found in degrees. In degrees, theta is approximately equal to 33 point, we'll say negative 33.4. All right. So now we're also going to find from here all the way to right there. So all you'd have to do really is just take 180 and subtract 33.4. So if I do 180 and took away that 33.37. So negative 146.63 is the other angle, right? So we have, so theta also in degrees is equal to negative 146.63. So I'm at negative 146.63 right here, and I'm also at negative 33.4 right there. Now, that right there is dealing with, that's if we were in degrees, not radians. Here it asks us to be in radians. I just wanted to show you what it was in degrees because it's easier to explain in degrees than it is radians sometimes. So all we're going to do is we're going to go over here. We're going to convert this to radians. So go over here. It's going to convert it to radians. So I'm at negative 0.58. Right? So all I'd have to do to find the other answer would take pi, which is 180 in degrees. In radians, pi is 180. And we're just going to take away take away 0.58. So that puts us also at negative 2.56. So right here in radians, I'm at negative 2.56. And over here, I'm going to put radians, R-A-D. I'll put a little box around it. Well, that's not a box, that's a circle. Put a little box around it. There we got negative 0.256 radians, and we're also at negative 0.58. I'll write it over here. negative 0.58 radians. And that helps me get to this point right here. And negative 2.56 radians gets me right there. That's theta from here to there. That's negative 2.56 radians. Now all we have to do to each of these is just simply add 2 pi times n. And on this one, we also add 2 pi times n. So I'll put a little plus. So that's all I'm looking for. I'm looking for two answers. Negative 2.56 radians plus 2 pi n. Negative 0.25. Oh, here we go. Looks like we got answer choice B. Negative 2.56 radians plus 2 pi n. And the other one is negative 0.58 plus 2 pi n. Because once again, we had our two answers are going to be in quadrant 4 and quadrant 3 for this particular problem. So I'm going to choose B and C for this problem. All right, and here's our last one. The last problem we're going to be dealing with, we're also going to be in radians, and we're going to find all the answers between 3 pi over 2 and 9 pi over 2. And then this will be the end of the video. All right, step number 1, what we're going to do is we're going to find what this is in radians. As a fraction, this would be 65 over 100. Obviously, you can reduce it. I didn't reduce the other one, but you could do 65 divided by 100. They're both divisible by 5, so it'll be 13 over 50. Sorry, 13 over 20. So we're going to go ahead, we can make that, apply that to our problem right here, 13 over 20, because they're both divisible by 5. And we could have also divided the other one by 5. But right now, where is this going to be located? This is going to be located in quadrant number 1 and quadrant number 2. That's where the y values are positive. Here the x values are negative, but the y values are positive. Over here, the x values are positive and the y values are positive. Sorry. Here we go. So we're going to go ahead and draw these two triangles out. We'll go over 13 and up 20. So let's see, we'll kind of go over, say, 13 and up 20. I know it's not perfect there. How about that? There we go. Up 13, just approximately. We'll just kind of do the exact same thing over on the other side as best as we can. Not perfect, but it should suffice for what we're doing. There's your right angle. There's your right angle. There's our triangle. All right, so what does that mean? That means this right here, I'm saying this side is 13 units, this side is 20, this side is 13 units, this side is 20. Just remember, sine is always the y value over the r value, y over r. So we are going to find theta right here, and we're also going to find theta from here going all the way, choose a different color, from here going all the way arced over to here, from here to there. There we go. I can draw a little bit better that way. So this is going to be the other way to get from the starting position, all right, from the initial side all the way to the terminal side. We call this the initial, we call this the terminal. Here's the initial, here's the terminal for our first angle. So we're going to get to this point on the unit circle, and we're going to get to this point on the unit circle, and we're going to stay in radians, okay? So first thing I'm going to do is I'm going to solve for theta, or solve for x. So if I have the sine of x equals 0.65, x will approximately equal, all right, whatever the inverse of sine of 0.65 is. So I'm going to first do it in degrees, and then we'll convert it to radians. All right, so I'm going to just keep pi right there. Inverse of 0.65, I get but that's in radians now. In degrees, that would be about 40.54 degrees. And there we are in radians. All right, so right over here, that's approximately equal to 40.54 degrees. That's our first one. All right, so if I say theta, that's our first theta right there, 40.54. The other theta, which is this theta right here in orange, all I would have to do was basically, I need to figure out how far to go from here all the way across. So what would I have to do to go from here to there? That's what you're looking for. Well, from here to here, right, is 180 minus 40.54 degrees. So all I'd have to do is take 180 and minus 40.54 degrees, which gives me 139.46. So 139.46 degrees. That's from here to there. So those would be my two answers in degrees. But what we have to do is we need to convert that into radians, which won't be very hard. All we got to do is go over here and just convert it to radians, which is 0.707. Now, if you wanted to do it just by hand, like how would you do that by hand? You would take 40.54 and you would multiply it by pi divided by 180. So now we have our radians, okay, which is 0.707. We could also basically take, what we're going to do is we are going to take pi, which is 180, all right, and we are going to take away this 0.7, you know what, we'll just take away this inverse sign. I'll make it more accurate. Take away the inverse sign of 0.65, all right, and you get 2.43. So just remember that, 0.70, we'll say 0.7075, 76, and 2.43. Remember these radians. I'll take a screenshot right here, and we'll just kind of highlight them. Remember this one right here, and remember this one right here. Those are going to be very, very important to help us figure out all of our answer choices. So let's go back to our problem real quick, all right? We need to convert 3 pi over 2 and 9 pi over 2. We need to convert those into decimal form. Let's see what those are. 3 pi over 2 and 9 pi over 2. Let's go over here, type in 3 pi divided by 2, all right? And then I'll type in 9 pi. These are our boundaries. 9 pi divided by 2. All right, so here we go. So we have some boundaries now. Okay. So basically what we're going to do is we're going to try to find all the answers between 4.71 and 14.13. That's what we're going to be trying to find answers. And we're going to have a couple of formulas that we're going to be using. All right, one of the formulas that we're going to be using to find all of these answers is we're going to do 0.7076, and we are going to add 2 pi to that and find all the possible answers between these two numbers. The other thing we're going to do is we're going to take 2.434, and we're also going to add 2 pi times n. We're going to keep doing this over and over again until we find all of our answer choices. All right, and then we're just going to select them one by one. So obviously, here's our answer choices. We're going to find all the answer choices from this list, and we're going to do that by these two formulas. Hey, give me a rectangle here. There we go. By using this one and using this one. Okay, so I'm going to go back here to Desmos. All right, and what I'm going to do is I am going to say plus 2 pi x. I'm going to delete all of them. I'm going to take this one right here and put plus 2 pi x. And I'm going to clear everything else. I'm going to clear this one out. I'm going to take a look at the table here. All right, let's take a look right here. Let's look at the table. I got a 6.99, so I think that's going to be 1. So I'm going to definitely do 6.99. Go back over here. Let's take a look at it. We got 13.27. Oh, that'll work because that's 14.13. So I got 13.27. So I'll go back over here. Take a look at that one. There it is. All right, 13. All right, let's take a look at this table here. All right, scrolling down. All right, looks like we got 8.717, so 8.72. There's an 8.72. That will be there. 8.71. That'll work. All right. So if you're wondering what the heck am I doing, all I'm doing is I'm taking 0.7076 and I'm adding 2 pi to it. Now, if you have a traditional calculator, you could do the exact same thing. It's going to put 0.7076. I'm going to add 2 pi, not 1 pi. 2 pi. All right, there we go. I'm going to add another 2 pi, not times. All right, and that's as much as we can get on that one. The other one, let's see, what was the other one that we looked at? Where was it? Oh, I think it was 2.43. Let me look, just make sure. Yep, 2.434. So I go over here and put 2.434 plus 2 pi. And if I add another 2 pi, I'm over the limit. Yeah, I'm over the limit on that one. Because what was our limit? Our limit was 3 divided by 2 times pi, which was 4.71, and it was also 9 divided by 2 times pi. All right, and that's too much. So basically, we just have three answer choices. We have this answer choice, this answer choice, and this answer choice. Those are all the ones between 3 pi over 2 and 9 pi over 2. And that's it. So, how did we do that? Once again, all we did, all right, quick, no, don't cancel. All right, all we did was we found theta right here. We found theta in orange, all right, knowing that we're going to be in the first and the second quadrant because that's where sine is positive. Once we found those, we converted those to radians, and it's very easy to convert it to radians. All you have to do is you could just start in radians if you wanted to and say, what's the inverse of sine? Which was 0.65. You got that, and then from there, all you did was add 2 pi to it over and over and over again to find your answer choices. All right, so we're going to be, if you have any questions, feel free to contact me. I hope you guys have a good day. All right, I realize there's a lot to take in, but just treat this as a class and try to get all of your, if you have questions, make sure you write those questions down and send them to me. Have a good day.